Chapter 7, Part 2. Ligamentous mechanoreceptors. Ligamentous mechanoreceptors are deformed during rotation and are mechanically sensitive to stretch. Movement of the joint in any limiting position results in sensory stimulation. Ligamentous receptors cause an increased level of response in the gamma efferent muscle spindle receptors, which are responsible for the appropriate muscle firing patterns necessary to help protect the joint during stabilization. Joint and muscle receptors work interdependently to provide optimum proprioceptive input for the central nervous system. Joint receptors increase the response when muscle mechanoreceptors are losing their ability to signal changes about angular displacement. This results in maximal sensory input at the central nervous system level and optimum neuromuscular efficiency. Nociceptor, small diameter afferents located primarily in articular tissue and sensitive to mechanical deformation and pain. Nociceptor, small diameter afferents located primarily in articular tissue and sensitive to mechanical deformation and pain. Central processing. Anticipatory postural adjustments play an important role in maintaining balance during the performance of any given task. Studies have shown that postural adjustments of the legs and trunk may be initiated before the onset of voluntary movement of the trunk or upper limb. Studies have shown that postural adjustments of the legs and trunk may be initiated before the onset of voluntary movements of the trunk or upper limb. When the support was unstable, the activation of the stabilizing muscles preceded the force production of the prime movers. Citation: reported anticipatory increase in activity of the anterior tibialis, biceps femoris, erector spinae, and rectus abdominis when standing in an unstable environment. Furthermore, it has been demonstrated that the transverse abdominis becomes active prior to actual limb movement, and this is pre-programmed. Activation was used as an anticipatory feed-forward postural mechanism in the core lumbopelvic hip complex. It is speculated that these anticipatory postural adjustments occur to minimize subsequent postural destabilization. Pro tip: it is important that the athlete develop strong core musculature in order to maintain his or her center of gravity and balance during athletic movements. A well-developed integrated training program, including core training, is integral to successful balance training. When athletes move, they are usually unaware of the complex sensory motor processes that occurs to maintain balance by keeping the center of gravity over their base of support. The complex sensory motor control process unite the proprioceptive feedback from the peripheral nervous system with the internal central processing within the brainstem and cerebellum to meet the constant demands of changing postures. Joint angles, torques, and so on during sport. To allow optimum balance and successful performance of complex motor skills. Scientific rationale for balance training. Page 249, Part 2, Chapter 7. Scientific rationale for balance training. Inefficient neuromuscular stabilization leads to abnormal stress throughout the human movement system. The human movement system will not respond to the demands imposed during functional activities if the neuromuscular system is inappropriately trained. Just as lack of joint stabilization predisposes an individual to functional instability, a lack of neuromuscular stabilization alters length tension relationships, force couple relationships, and joint kinematics, decreasing balance and performance, leading to tissue overload and possible injury. As the efficiency of the neuromuscular system decreases, the ability to maintain appropriate forces also decreases. This leads to compensations and altered movement patterns, which then leads to excessive mechanical loading in both contractile and non-contractile tissue. The human movement system is only as strong as its weakest link. The central nervous system will allow recruitment of the prime movers only to the degree that the body maintains dynamic joint stabilization and postural equilibrium. The human movement system will break down at the weak link or transfer forces elsewhere, which can lead to tissue overload, compensation, adaptation, and further altered patterns. Each tissue located in the human movement system breaks down at a different rate, referred to as the stress continuum. Each tissue located in the human movement system breaks down at a different rate, referred to as the tissue stress continuum. Microfailure occurs in the collagen tissue. Proper balance, optimal stability, and neuromuscular control. Proper recruitment of prime movers, optimal integrated movement pattern, enhanced performance, and decreased injury. Central nervous system. Improper balance, altered stability, and neuromuscular control. Synergistic muscles are recruited, leading to compensation. Faulty movement patterns, decreased performance and injury. Faulty movement patterns, decreased performance and injury. When the tissue is deformed by as little as 6 to 8%. Therefore, with lack of balance, the human movement system compensates with an altered, less familiar motor pattern in order to maintain force production. When this compensation transfers forces to a weaker link in the human movement system, alteration in stability and neuromuscular control occur. The central nervous system selects optimum movement strategies to maintain adequate force production. If a prime mover is weak or slow to activate, synergistic muscles are utilized to maintain force production. Synergistic muscles fatigue more quickly and lack the precise neuromuscular control that the prime movers provide. This leads to faulty movement patterns, decreased performance, and injury. Research has demonstrated that balance training restores dynamic stabilization mechanisms, improves neuromuscular efficiency, and stimulates joint and muscle receptors to encourage maximal sensory input to the central nervous system. Maximal sensory input to the sensory nerve. Seeing this. Acting collectively, this improves proprioception, kinesthesia, neuromuscular efficiency, central processing, which in turn can improve performance and decrease injury. Guidelines for balance training. Balance is a component of all movements, whether dominated by strength, speed, flexibility, or endurance. In sport, balance does not work in isolation. Therefore, it should not be thought of as an isolated component of training. An integrated training program requires incorporating balance training into a comprehensive, multi-component training program of flexibility, core, plyometrics, speed, agility, and quickness, resistance, and cardiovascular training. The main objective of balance training is to continually increase the athlete's awareness of their balance threshold or limits of stability by creating controlled instability. Designing an integrated balance training progression requires creating a proprioceptively enriched environment and selecting the appropriate exercises. A balanced program should be based on science with a systematic, progressive, and functional approach. Designing an integrated training program requires selecting the appropriate exercises. The exercises must be safe, challenging, stress multiple planes of motion, incorporate a multisensory approach, and be derived from fundamental movement skills that apply directly to an activity. When designing an integrated balance training program, the sports performance professional should follow a continuum of function. The exercises should progress from slow to fast, simple to complex, known to unknown, low force to high force, static to dynamic, 2 arms to 1 arm, 2 legs to 1 leg, stable to unstable, eyes open to eyes closed, and most importantly, quality before quantity. A balanced training program, page 252, chapter 7. A balanced training program can be progressed by adding external resistance. External resistance comes from many forms including tubing, dumbbells, medicine balls, power balls, barbells, kettlebells, machines, sandbags, and other forms of external resistance. Proprioception should be the key to progression, and external resistance is added as each movement is mastered appropriately. Balanced training program. NASM has designed a systematic progression and the OPT model.